Thanks, Paul, and thanks for the warm welcome, and thanks to everybody for attending today. As Paul said, I thought we could talk about multi-arch computing with OpenShift and Power Systems today. It's a very new topic, essentially, but we'll talk through some of the history, maybe look at some demonstrations as well. The presentation, I understand Paul will make available to you. I've just added one slide to it from the Common Europe Congress 2 weeks ago. Although that session was an hour, so at least double, maybe 3 times as long. So I don't really expect to drill down as deep or possibly even to go through all the different slides. But they will be there for your review, and please feel free to come through to me, email, Slack, phone, whatever, anytime for any assistance with multi-arch compute and power systems with OpenShift. So the topics that are on the agenda, a little bit about the history, strategy, why IBM and Power are doing this, and maybe even a little bit of why Red Hat are doing it. What you need to do to prepare for an installation of the example we're going to use is the Sock Shop. It's an open source e-commerce website tool, and the idea is to deploy it in a cluster whereby we can have both x86 and Power nodes. We can talk about the actual installation of the Sock Shop, then navigating the application, the solution, reviewing some of the worker nodes and the pods that form part of that solution. And then we get into how can we use this to our best advantage, cordoning, taints and tolerances, so we can specify where our different workloads go. Possibly we may not have time to look at the actual installation of multi-arch itself, sharing some public references, and also where you can go for additional resources, because there's a growing amount out there right now. So before I get stuck into the history and start kicking off there, I think what I'd like to do is just show you what we have today for the demonstration area. So this is the OpenShift console GUI, and this is actually the Sock Shop. Looking at topology view at the moment, there's about 12, 15 different containers, a mixture of Python, Go, Java, .NET, all different systems talking to each other to provide the solution. If we click on this here, then that'll take us to the web shop itself, where we've got a catalog and the whole solution there. And we can use the GUI to do anything that we like. Things that we can do in the GUI, we can also do via the command line through the API server. This is just timed out, so I'm going to have to re-log in. Apologies for that, but as that's just sorting out, we can also look, and I have a command prompt for my Windows command prompt system there as well for doing the command line stuff. So let's just log in here. And here we can see I'm just doing a watch on the pods for that Sock shop, and we can see that it's all running, what nodes it's running on, etc. So we'll come back to that. So as I said, we can see that the Sock Shop is actually already installed, but what I'd like to do is just to show you it being installed. So the first thing I'm going to do is remove the Sock Shop, and to do that I'm just going to use one command. It'll check for all manifest files. And we're going to use the customize command. So that actually allows us to use the standard config files, but customize them. So we keep the original config files as is, and then can customize them as we like. So as I hit this, we should see the containers and the pods disappearing. If we look on my other system here, which is watching all those pods, they will all disappear as well. And then it's all in its own namespace at the moment. So we can see the Sock Shop is there. If I go to all projects and then come back down again, it's actually gone away now. so there's no resources shown in the sock shop space. So this is all deleted. It's removed each of the containers and the pods. It's removed the persistent volume claims, the storage. And what I'm going to do now, the reason I want to do this is because when you start up the 15 microservices to begin with, 2 or 3 of them take 3 or 4 minutes to settle down. There's health checks involved. So it takes a little bit of time. So what I want to do is kick off the installation, and then we go back to the presentation, and then you can see it all up and running again afterwards. So very similar again. I'm just going to use the customize command. Instead of saying delete, I'm saying apply here, and this is a manifest file. So we can see, we can see here that the containers are starting to be spun up. Here we see that this is the carts database, the catalog, the front end, orders, all the different components of the solution that are used. And we also see the readiness, so 1 of 1 container running, 0 of 1 here, so that's still starting up. And that'll happen for the majority, it'll happen quite quickly. But for the last 2, I think it's the catalog database. As I said, because of the health check, it takes a bit of time for that to spin up. So I'm going to leave that now. Yeah, most of them are running, so we're just missing the catalog, payment, and the user. And I think the payment will be the next one to start, and then a couple of minutes for the others. So that being the case, I'm going to go back to the presentation. And the history of multi-arch compute within OpenShift. So previously, if we were running different processor architectures, Power 10, C, x86, ARM, etc., they would all have their own cluster. And that meant they would all have their own control plane, which is typically three nodes for the control plane. And then you typically have 2 or more worker nodes as well. So you can see that if you did need to run multiple architectures, then you start using a lot of resource. The other complication there is OpenShift takes care of almost all of our networking between the API and the different microservices and stuff. But when you have different clusters, it's certainly not impossible. We use Submariner for demonstrations for this, but it's far simpler for the networking if it's all within one cluster. And previously, we were unable to do that, or added complexity, shall we say. The other thing is that if you've got a cluster, if a customer has already been running OpenShift on x86 for a number of years, and they have some applications that would be better run on Power, either due for performance or co-location, security, whatever the reason being, and you wanted to move that workload over to Power because it was in a different cluster, that's also complicated. So now, as of OpenShift 4.14, which GA'd last November, we could now have an OpenShift cluster and run multiple architectures within it. So we could run Power 10 and x86 in the same cluster, for instance. Now, the thing to be aware of, and it probably in the next year or 2, it won't be so important, but because it's still very new, from 4.14, that's the OpenShift version, the control plane must be on x86. So that was the first release. And actually that was November last year, but in summer of last year was the first Red Hat OpenShift release of multi-arch, and that was for x86 and ARM. So ARM got it probably 4.12, possibly 4.13. We got it in 4.14 for Power. And then in the release in February or April of this year, we got 4.15, which then allowed us to have the control plane on Power as well. So I tend to really share these kind of things on LinkedIn. So within the presentation, there's a link to that. Also share the link to the release notes, etc., for more clarity and detail on the announcement. Now, if we look at the strategy, IBM strategy, clearly over the previous years, they've been moving more and more of the IBM solutions and applications to a containerized format. Likewise, many other organizations and developers with DevOps around the globe. So Power is falling in line with IBM and others with new technology, new ways of delivering applications. And what we tend to do is we can surround core applications. So by that, I mean, if we've got databases or statements of record, etc., then we can bring in containerized solutions around the outside of that to add more functionality seamlessly without taking downtime from maybe the traditional application or the data, etc. We can refactor applications to new microservices, and this is going on all the time. There's a link at the bottom here for the CNCF, and it lists all the containerized type solutions. There's probably over 1,000 there that we can put together for what we might call, fit for purpose or best architecture. And we also have ISVs, HCL Commerce, for instance. I work with SME up in Italy. They're all actually taking their core ISV applications and containerizing it. And sometimes they use applications or components that aren't supported on Power today. So actually, the ability to run the OpenShift cluster with x86 applications along with those that they can on Power, and then the traditional backend core applications is of huge benefit. Also within DevOps, if we have a large organization whereby they would have Power 10 and Intel and maybe Z as well, the developers are developing and checking their code and testing all on different clusters, whereas with multi-arch compute, we've got a single control plane, we have different worker nodes for each of the architectures. So it's very much simplifies the whole process, which speeds up time to market, etc. So that's very helpful. These are taken from Red Hat's slide deck. And as I mentioned before, they see that multi-arch provides an easy way of migrating between different architectures. Also cost optimization. So we have some customers that, as I say, they're already running OpenShift on x86, and they might want to run some applications on Power, but they don't really want to make a whole new cluster because then they're doubling up on the control plane. And of course, with multi-arch compute, you don't need to do that. The other thing to consider, of course, is that we tend to get many, many more times containers per core or per server than x86. So we have a higher density and a better economic forecast for that too. So that's some things that Red Hat look at. So I'm just going to take a quick look back at how our installation's going. We can see now that all of them are running. They're all at 2 of 2. We can see which worker nodes they're on as well. So that's good. Okay. So preparing for an installation of the SOC Shop. So the SOC Shop is an open source e-commerce application. I call it an application rather than a solution because it's a plaything. It's actually for developers to get used to microservices. It was developed about 8 years ago, I think, by Weaveworks. What our developers in Power did, they looked at this and it's a great example because it uses many different languages. So we ported it or made it run on Power, and now we can run it in multi-arch, so it runs on both x86 and Power, and you can move things around. So this is what the front page looks like from the site. I'll make it full screen for you. It's available from GitHub, so you can actually clone this and run it on your own systems if you like. The links are all in the presentation there for you. And this is the architecture of the application. We have a front end that's written in Node.js that the users come through with a browser. We have Java, or you can have .NET Core for the orders process. Then we've got the payments, microservices, user, catalog, all using the Go language. Java running cart with some databases, some MongoDB and MySQL, for example. with some more Java for shipping and RabbitMQ for queues. Now, what we tend to do, I mentioned earlier that we have customize command, so we use the same config files, and we just make customizations so that we can use the original and then adapt it as we like afterwards. And this is how all the microservices look when they're talking to each other. Again, the user comes in via HTTPS. All the different microservices are listed down here. This slide isn't truly accurate because it says some Intel only and not Power, etc. I think there's only one case that we're using that's Intel only on here, but the rest we can move around. And we use NFS storage for the persistent claims, etc. There's another slide in just a moment, but we've got all the images stored in Quay. And actually, if we go to Quay, we can see that. So again, you've got the links, and we can see here we've got the carts, the catalog, the sock shop, and we've actually got an image there for all four. So for Z, for x86, for Power, for mainframe, etc. Let's find the presentation again. Okay, so that's where we're storing the images at the moment. You can go there, take a look, filter by the sock shop. So installing prereqs. So first of all, I'll install Git. So that's just a DNF install Git. Install customize, and we run a curl command and pipe that through bash, which installs the binary there. I just add that to the path. Remember, 4.14 has to have an x86 control plane. 4.15 provides a Power control plane. 4.16 is due out next week, and we have more multi-arch features being GA'd along with that. So here we're cloning the project from GitHub. We have to add some secrets, so this is just the password and the user ID for the MongoDB database. We copy the file in place for that. And all of that was done before. We're just leading up to the stage where I showed you earlier where we installed. So then I typically go to the console, the OpenShift console, copy the login command and pop that into PuTTY or my command line interface to give me access to the cluster. And this is just taking us now to the stage where we were at, where I showed you both the removal and the installation of the sock shop. So here we CD into the sock shop demo. We use the customize command and apply the manifests and the YAML files, and then it goes through. This is what you actually saw live just a moment ago. And then the topology view. Note that a dark circle means it's installed and stable and ready, and a light circle means it's being built. Red would be a problem. And then the solution is up and running. So I'm not going to spend any time on this as such. I'm just going to flash through it, but the screenshots are there. So we can run a command, OC get root, to tell us what the URL is to access the application. And then we get to the front page. We can log in, we can register, we can search the catalog for different colors or different types of socks, etc. We can place orders, add credit card information, shipping addresses. So it's a real good e-commerce site. It's very good for developers to use or test. There's also load tests, so you can run it and compare the differences between different platforms, etc. So we can have a look at this live, but we haven't got very much time today, so I'm going to go through very quickly here, placing the order. So reviewing nodes and pods. So I'm going to go back to our own system here, and there's some videos online where I've shared on YouTube, etc. And usually I've used the command line, so I thought today that I'd do the opposite and do more on the GUI. So if we change to the administrator view and then look at the compute and the nodes area, then we can see that we've got the three control plane nodes, and then we've got two worker nodes. So we've got worker 0 and worker A0. Now, if we click on worker 0, we can see in the detail section that this is actually Power PC. So worker 0 is our Power worker node. And if we do the same and look at work at A0, follow the details, then we can see that's actually AMD. Now we can cordon, and that means to stop scheduling of new workloads on a particular worker node. So if I just take a look back, this is our 15 microservices containers that are running for the solution at the moment. They're all up and running. At the moment, you can see that I cordoned, I stopped scheduling to the Power worker node. So they're all running on the x86 worker node. So if now I uncordon and mark that as schedulable, but I now say that the x86 worker node is unschedulable, then we should be able to go back to the developer view. Developer topology, and if we search for the front end, sorry, I'm in all projects. I haven't switched to the sock shop. Right, here we go. So here's the front end. And as I said, if we click the URL, then that will actually take us to the front end of that application. It tells us here that this pod is running, so we can look at that in more detail. We can see that it's working currently on worker A0, which we could tell by the command line earlier on, and we could also tell that that was an x86 environment. So now if we actually take that and we delete the pod, and then I'm going to go very quickly back down here, we can see that the front end is now in a container starting state. So that's now actually restarted up. And if we refresh the screen, what you saw earlier was running on x86, and now this is running on the Power node. We can see that because now it's working on worker 0 that we previously looked at and could tell that was the Power node. So there we've been able to take an application that was actually written for x86 some 8 years ago, before Power was supported with OpenShift at all. We've been able to make that run on Power x86 mainframe and ARM, store the images for that by IO, and with multi-arch compute that we got GA'd last November, we can then run mixed architecture clusters within OpenShift. And you know, I'm working with several customers. There's some public references already. There's another one due to be released. There's an internal one next week. I think the public one will follow shortly afterwards, of different customers using this kind of technology for a number of different reasons, in actual fact. So time-wise, we're looking, I think, at 5 minutes left. So I'm just going to try and share some more from the presentation itself. So Sockshop demo, yes, this is where you can clone it from the, actually we've been through this, haven't we? Let me catch up. So installation, we've done that. Navigate to the Sockshop, let me fly through. Reviewing the nodes. So via the command line, we can do OC get nodes, and then that shows us the same information we looked at through the GUI earlier on. We can run that through a -O wide, and then we could actually tell, so just down here, if you can see my cursor, it's telling us that worker A0 is x86 and all the rest are Power. We can look at the pods. By adding different field selectors, we can say, actually just show me the pods working on the x86 node, or just show me the front end, or just show me what's working on the Power node. And the next part is about the cordoning. So this is what you saw us do through the GUI. We cordoned the x86 node so that no workload would be scheduled to that. We then looked at the front end container and deleted it. Now OpenShift looked at that and said, okay, it's been deleted, it should be running, so it restarted it. It couldn't restart it on x86, so it started it on Power. and therefore a seamless migration of that workload from x86 to Power. Again, we can use the -y to give us more details of the pods, just like we looked at in the worker nodes and the control plane earlier on. Now, the next couple of slides are ways that we can manipulate this and use it. So node selectors are a way of saying, actually, we want to limit workload, and perhaps we only want this type of workload or this container to run on a Power node, or maybe we just want it to run on an x86 node, and we can add this to the YAML file to achieve that. There's a link there to a blog with more information on it. We can also use taints and tolerances, where we can say, actually, with node affinity, you can say, I would like to attract specific workloads to a group of worker nodes, or with tolerations, I think it is, where it can say repel, so we don't want to run some workloads on different worker nodes. But this is all kind of adding additional lines in the YAML files, etc. There's further information in the links there. What's just about to come is the multi-arc tuning operator. So this comes with OpenShift 4.16, which I'm expecting next week. And this makes life a lot easier for controlling solutions and determining what workloads are positioned or scheduled to different architecture platforms, etc. It's already up and running. The system I showed you today is actually a development system, so it's actually got this running on it already, even though that's not GA. And that will be available from next week. So perhaps I could do another brunch and learn and show some more information on that when it's GA. So just a little bit about the installation process. When you install OpenShift Multi-Arch Compute, you don't really install multi-arch, you actually install it as normal with just one architecture. So that might be x86 or Power, and then you go through what we might call a day 2 operation to add multi-arch capabilities to it. So this is the process for a normal OpenShift installation, and that takes, I think I'm doing a webinar showing 3 different ways to install single node OpenShift next week. That takes about 45 minutes to an hour. The process to add multi-arch to it takes again another 45 minutes to an hour, and this is the list there. Now, I appreciate we're coming up to the bottom of the hour now. So just to call out that there is some other GitHub projects that the development team are working on to simplify and automate adding multi-arch and additional worker nodes, whether that be adding Power to IBM Cloud, or adding Intel to Power Virtual Server, or indeed adding Intel to on-premise Power VM, Power VC systems. Public references. This was the early adoption process, a 90-second video that's available online, where I introduced multi-arch last November. I worked closely with SMEUP, who went through the process and did a presentation in Barcelona for the Tech Exchange on it. So we have a public reference that's available for download, and all the links are here. And this is just 3 of their slides from their presentation that they used. And I think then we just wrap up almost on time with some additional videos. So brunch and learn that I did last November, a demo installing SockShop in multi-arch, an edited version, so it's only 3 minutes to show the migration of workloads between architectures with multi-arch, Cloud Pak for Data working on multi-arch, a webinar from Paul Bastide, chief developer, who I worked closely with. So kudos to him. He's been working on this project for 2 years to deliver it. And I've been working with the Red Hat Red Book team. So we're hoping to finalize the draft copy of a Red Book on this topic for publication for next month. So keep an eye out for that. There's a whole bunch of demonstrations, YouTube clips, blogs, etc., with more information here, should you want it. But please remember that you can reach out to me and Paul Bastide and the team, and we'd like to hear from you and how this could help, and we'd like to help you make that a success. So with that, thanks for your time. I'll hand back to you, Paul.
Thanks very much, Paul. I thought that you made that really clear. That was good. I hope to see you on Britain's Got Talent soon, doing that demo. I've got 2 questions that I know we just run over, but I'll ask the questions. Does IBM software make use of multi-arch computing like Cloud Path for Data? Is that in the roadmap?
So it is in the roadmap. We're working on it now. So there's a video I showed you just a way back, and that's actually a Cloud Path for Data, for instance, working with multi-arch compute. But we've kind of knocked it into shape, as I said, to use these taints, tolerance, node selectors to tell the system where to schedule the workload. We have to add a line to the YAML file, etc. So that's not necessarily what a big complex solution like Cloud Path for Data would want. And that's why we have this, did put it in there, didn't I? So I thought I added it this morning. It's the only slide that I added that wasn't in the link that I gave you. A quick look down this way. Yeah, so it's the multi-arch tuning operator. I think I've got, yeah. So there's a GitHub project, multi-arch tuning operator, and this is the step to make it easier for the IBM solutions with all the cloud packs to make good use of multi-arch compute. So we're working through to make that GA now.
Okay.
And if anybody wants more information about that, please come through.
And there was a question asked about could you modify the demo to show what's next on 86 what's next on x86 and doing inferencing on Power 10?
Yeah. So that's a good point. So I've worked with CSI on a lot of the early adoption stuff with hybrid cloud. We've recently been putting a lot of AI, MMA type inferencing on their CSI Tech Labs, and I presented with them in Milan for the Common Europe Congress 2 weeks ago as well. So they have storage fusion with GPUs, and they have Power 8 and Power 10 in their Tech Lab. So we're in the process of setting up multi-arch compute across Power and x86 there to show training with GPUs and then inferencing with Power. But yeah, that's one of the strong use cases today.